Let me show you what I mean. You might say, well, magnets attract because of magnetic fields. Okay, but why do magnetic fields make things attractive? Because of the electromagnetic force, right? But why does the electromagnetic force work the way it does? Because of quantum electrodynamics. Sure. But why does quantum electrodynamics have those particular rules? You see what's happening here? Every answer just pushes the question back one level. It's like asking why. Eventually you hit bedrock. Eventually you reach something where the only honest answer is that's just how nature is. We've discovered the pattern. We can describe it beautifully, but we can't explain why the pattern is what it is rather than something else. And this isn't a failure of physics. This is the nature of understanding itself. Think about it this way. If I tell you that magnets attract because of property X, you can ask, why does property X cause attraction? If I answer with property Y, you ask, why does property Y work that way? At some point, we reach the fundamental properties, the ones that don't come from anything else. They just are. The universe has to work some way. It has to have some rules, and these are the rules it has. Now, people don't like this answer. They want to know why, really why, deep down why. But here's something interesting. In everyday life, we never ask why this way. I push a door. The door opens. You don't ask me, but why does pushing make things move? You already accept that pushing makes things move. That's ordinary to you. But magnets are strange. You can't see anything between them. There's no string, no rod, no obvious connection. So you want an explanation that reduces it to something familiar, something ordinary. But here's the problem. Magnets are ordinary. They're not weird. They're not magic. They're just as fundamental as pushing. More fundamental, actually. Because when you push a door, what's really happening? The atoms in your hand are getting close to the atoms in the door. And the electrons in your hand, they repel the electrons in the door. Electrically, it's electromagnetic force all the way down. You never actually touch anything. You just feel electromagnetic repulsion. So the ordinary pushing, that's magnetism too. Or electricity, same thing, different aspect. Everything you think of as solid, as tangible, as directly caused, it's all electromagnetic forces between atoms. The chair holding you up, electromagnetic. The floor beneath your feet, electromagnetic. The feeling of touching your own face, electromagnetic forces between the atoms in your hand and the atoms in your face. None of them are actually touching. They're all pushing each other away with electric fields. So when you ask me to explain magnetism in terms of something more familiar, you're asking me to explain the fundamental thing in terms of something less fundamental. It doesn't work. Let me put this another way. What is an electric charge? Why does an electron have the charge it has? I don't know. Nobody knows. We can measure it. We can tell you exactly how much charge an electron has. We can predict with extraordinary precision what that charge will do in any situation. But why does it have charge at all? Why not some other property? There's no answer to that. It's a fundamental feature of reality. The universe has electric charge. That's just a fact. And magnetism is just electricity from a different point of view. I'm serious. If you see a charge sitting still, you measure an electric field around it. But if you're moving past that charge, or if the charge is moving past you, you measure both an electric field and a magnetic field. They're not separate things. They're two aspects of the same underlying phenomenon, electromagnetism. What you call electric and what you call magnetic depends on your motion, on your frame of reference. They transform into each other. Einstein showed us this. Relativity doesn't just apply to space and time. It applies to electricity and magnetism too. So when you hold those two magnets, feeling them push or pull, you're feeling a consequence of relativity, of the fundamental symmetries of space and time. You're feeling the universe's way of keeping things consistent across different perspectives. But why does the universe care about consistency? Why does it have these symmetries? Because that's the universe we live in. That's bedrock. Now, here's where it gets beautiful. Even though we can't say why the electromagnetic force exists, we can describe how it works with astonishing precision. Quantum electrodynamics, QED for short. It's the most accurate theory in all of science. We can predict the magnetic moment of the electron, we can calculate it, and then measure it. And they agree to better than 1 part in a billion. Imagine predicting the distance from New York to Los Angeles to within the width of a human hair. That's the level of precision we're talking about. And how does QED work? It says that charged particles, electrons for instance, they interact by exchanging photons, virtual photons, little packets of electromagnetic field that pop in and out of existence, carrying force between particles. An electron emits a photon. Another electron absorbs it. And the result is that they push apart or pull together. It sounds crazy, but it works. It works better than any theory has any right to work. But even this, as beautiful and accurate as it is, even this doesn't tell us why. It tells us how to calculate the force. It gives us a procedure, a method. Here's how you add up all the photons, all the different ways they can be exchanged. Here's how you get the right answer every single time. But why do electrons exchange photons? Why does that produce force? The theory doesn't say. The theory just describes the pattern. You might think this is unsatisfying, and in a way it is. We want ultimate explanations. We want to reach the final why. But think about what we've accomplished. We've taken something that seems magical, magnets pulling across empty space, and we've connected it to electricity, to light, to relativity, to quantum mechanics. We've shown that it's all one thing, one unified pattern, electromagnetism. We've reduced thousands of separate phenomena to one framework. Lightning and radio waves, magnetism and static cling, the color of the sky and the way your eyes detect light. It's all the same force. That's not nothing. That's extraordinary. We haven't reached the final why, and maybe there isn't a final why. Maybe the universe just is. But we've mapped out vast territories of reality. We've found deep connections. We've unified. Here's another way to think about it. Every explanation has to start somewhere. Every chain of reasoning has a first link. In mathematics, you have axioms, statements you accept without proof. You need them. You can't prove everything from nothing. You have to start with something. Physics is the same way. We have fundamental laws, fundamental forces, fundamental particles. These are our axioms. We discover them by experiment. We test them, refine them, push them to their limits. But at some point, we reach the bottom, the things that just are. And you know what? That's okay, because the game isn't to explain everything in terms of something else. The game is to find the most fundamental patterns, the simplest set of rules that describes the richest set of phenomena. And we've gotten pretty good at this game. 4 fundamental forces, a handful of particles, a few symmetries, and from these, everything. Atoms, chemistry, biology, stars, galaxies, you, all from those simple ingredients following simple rules. But people want more. They want to know why these rules and not others. Why this universe? Let me tell you something. That might not be a physics question. That might be a metaphysical question, or it might not be a question with an answer at all. Maybe the universe doesn't have a reason. Maybe it just has a description. We describe it, we predict it, we understand the patterns. But the reason it's this way rather than some other way, there might not be a reason. It might just be, or maybe there is a deeper level. Maybe there's a more fundamental theory we haven't found yet. String theory, quantum gravity, something else. Maybe that theory will explain why the forces have the strengths they do, why the particles have the masses they have. And that would be wonderful. That would be progress. But even then, even if we find that deeper theory, it will have its own rules, its own axioms. And you'll be able to ask, why those? The question never ends. There's always another why. So what do? We do physics. We observe, we measure, we calculate, we test, we find patterns, we make predictions, we unify what seems separate. We discover that magnetism is electricity, is light, is relativity, is quantum fields. We build this incredible structure of understanding. And yes, at the bottom, there are things we take as given. But look at everything we've built on top of them. Look at how far we've come from wondering why rocks fall and magnets attract. Now, let me tell you something else, something important. When I say I can't tell you why magnets attract, I'm not saying we don't understand magnetism. We understand it deeply, profoundly. We understand it better than almost anything else in nature. We can predict magnetic behavior with extraordinary accuracy. We can build MRI machines and electric motors and hard drives. We can manipulate magnetic fields to do whatever we want. That's understanding. Real, practical, deep understanding. What we don't have is a certain kind of philosophical satisfaction, the kind where everything reduces to something that feels intuitively obvious. But nothing is intuitively obvious. Your intuition was built by your experience. You experience pushing things, so pushing feels obvious. You don't experience electromagnetic fields directly, so they feel mysterious. But to an electron, if an electron could feel, electromagnetic fields would be perfectly obvious. That's just how it moves. That's its world. Our intuitions aren't a guide to what's fundamental. They're a guide to what we've experienced. And physics takes us beyond experience. It shows us how things really work, not just how they seem. When you hold those magnets pushing and pulling, you're not holding something mysterious. You're holding one of the fundamental forces of nature, one of the 4 interactions that make everything happen. And yes, we can't tell you why it exists, but we can tell you what it is. We can show you how it connects to everything else. We can demonstrate its deep connection to symmetry, to relativity, to the quantum world. We can show you that it's beautiful, mathematically elegant, precisely described. That's not a failure of explanation. That's the triumph of physics. The universe doesn't owe us an intuitive explanation. It doesn't have to make sense in terms of everyday experience. It just has to be consistent. And it is staggeringly consistent. The same laws everywhere, the same constants, the same patterns operating from the smallest scales to the largest, from quarks to galaxy clusters. That consistency, that unity, that's what we've discovered, and it's magnificent. So when people ask me why magnets attract, I tell them what I've told you. I can describe it, I can calculate it, I can connect it to everything else we know. But why? Why this force rather than some other force? Why these rules rather than other rules? I don't know. Nobody knows. Maybe someday we'll find a deeper answer. Maybe we won't. But right now, at this moment, this is where we are. We've mapped the territory. We've found the patterns. We've unified vast swaths of physics into single elegant frameworks. And we stand here at the edge of our knowledge, looking out at the questions we can't yet answer. And you know what? That's where the fun is. That's where the adventure is. Not in the things we know, but in the things we're still figuring out. Why do the fundamental constants have the values they do? Why is the universe this way and not some other way? What's more fundamental than quantum fields? These questions don't have answers yet. Maybe they never will. But asking them, pushing at the boundaries, that's what makes physics alive. And you want to know why magnets attract? I've told you as much as anyone can tell you. They attract because of the electromagnetic force, which comes from the quantum field, which obeys certain symmetries, which exists. That's where it bottoms out. But along the way, look at everything we've learned. Look at the structure we've built. Look at the predictions we can make. Look at the technology we've created. Look at the understanding we've gained. That's not nothing. That's everything. The universe works the way it works. We describe it. We don't explain why it's this description rather than another. Maybe there's no why. Maybe there's just what is. And what is strange and beautiful and mathematically precise and deeply interconnected. Magnets attract, charges repel, light propagates, quantum fields fluctuate, and all of it follows patterns we can write down, calculate, and test. That's astonishing. That's enough. That has to be enough because that's what we have. And honestly, it's pretty wonderful.